Now we are going to learn about the statistics in R. Let's learn about what is the basic statistics. As certain definitions are given here regarding to basic statistics, statistics is basically the science of collecting, organizing, presenting, analyzing, and interpreting data to assist in making more effective decisions. So with the help of statistics, basically, we make the data summarize, we make the data collected, we organize the data, we present the data, we summarize the data and analyze the data and interpret that data to understand that what the data is speaking to us, and that data is based, that complete interpretation is based on to the group of numbers and observations. So that interpretation is based on to the data. So group of number or observations itself means the data. So here we put all the details of summarizing, analyzing and interpreting onto the data. So basically into the statistics, data is everything. So we collect the data and we make the factual decisions onto the base of data. So what we can do with this data? We can just do the mean, median, mode, range, we can find out with this data. So slowly we are going to learn all these things now. When we work with the statistics, there are types of data actually. So data are divided into two categories such as categorical and numerical data. Categorical data are just like the string data where we are having all the data into the ABCD formats. So they are into the category. Suppose here one is a political party or what is a gender. So male, female are the categories. It is a categorical data. Suppose marital status is there, married, unmarried, single. These are again the categories are present there. Any political parties, Democratic Republic or any other. So these are the category data. So we call it a categorical data. Now coming to the numerical data, again, wherever we are working with the numbers, they are counted as the numerical data. The numerical data is divided into two, the discrete and the continuous. Discrete data are just like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And continuous data are just like you are taking your height, weight, uh, any particular measurements you are taking, suppose any prices, house prices. So it means they are having into the data into the decimal format. Suppose any billing, electricity bill is there. So electricity bill itself is a decimal format. Anybody is having suppose 400.50 paisa. So that one is a continuous data. Anybody is having a height. Suppose height is 5.7. So point is there, decimal is there. So that one is a continuous data. Coming to the discrete level, suppose how many hours one is studying. Suppose 5 hours, 8 hours, 12 hours. So directly numbers are there. How many children are there like per person? So suppose 2 children, 1 child is there, 3 children. So there's a specific figure is there into the discrete. So that becomes from whole numbers such from 0 to 9. So these are the descriptions, same for the discrete data and the continuous data. Now coming to the categorical or nominal data, we can call the categorical data as the nominal data. So what kind of data we are having? We can have such like you can see gender and male and female. Suppose country is there. A particular country is there, US, UK, UAE, India. So these are all categorical data. We can call it a nominal data as well. Now coming to one more type of data, suppose an ordinal data. What are the ordinal data? Ordinal data are suppose the rating we do after using a particular product. Suppose one is purchasing anything from Amazon. So once you had just, you are rating the services 1, 2, 3, 4, 5, or there's a 5-star rating also. Suppose one is taking the pizza delivery, or one is using any particular Ola cabs, Oyo hotel services, or any other services one is taking. So one is giving the ratings after every services one is used, that one. So once you are taking that services, one has to give the ratings there. So that one is a 5-star rating. So if you click onto the 1-star only, so it means services are not good. 3, you are clicking, so it means services are average or moderate. And if you are clicking a 5-star rating, so in that way, if one is accommodating in any hotel or you're taking the flight services, so you are giving the ratings to that services. So that one is coming as an ordinal data. Interval data one can see. Suppose here inside the interval, certain gaps are there. One is giving certain temperature related data. Suppose 0 to 10 degrees Celsius or 11 to 20 degrees Celsius. So these are a kind of interval data. Now let's understand certain more terms here. Population. Population. What is a population? Population means a huge amount of data. Suppose here I'm having a 5,000 data of 500 students. So suppose here these are the data related with student weight. Weight. So I'll call those 5,000 student as the population. So if I'm having a 5,000 student data and those data are related to their weight, average weight, okay? So it means that one is what? That one is the population in terms of statistics we can call. But suppose here I want to find out the average weight, average weight. So there what we can do, instead of taking all 5,000, I can just select randomly any 500 people. So I can just take any 500 student data instead of 5,000. So this 500 is known as a sample. So population is large and we are taking the data from population. That one is a subset of, sample is a subset of the population. Suppose here there are a number of cars. I want to take a sample uh, sample mileage, average mileage of the cars. So I can't take all the cars because all the cars are the population. I'm just taking the sample of the cars. So only few selected cars we can take and find out the average speed of the car. Now, whenever we are talking about the statistics, so there is a main one, descriptive statistics. So descriptive statistics is used to describe, summarize and organize set of different measurements. Measurements itself means the data, observations we can talk it. Now there are two parts of descriptive statistics. We call it a central tendency and the dispersions. So now there are different details inside the central tendency and the data dispersions. So now we are going to look at one by one all the details of the mean, median, mode inside the central tendency and then coming to the data dispersion. Now let's learn about the descriptive statistics in detail. Descriptive statistics has the two parts, the central tendency and the dispersions. Inside the central tendency, there are certain mu terms such as mean, median, and mode. And when we work about the dispersion of data, so there is a range, variance, and the standard deviations are present. Now let's take about certain samples about the central tendency. What is the mean? Mean is what basically that one is adding all the data divided by total number of count here. So sum of data divided by total number of count, that one is a mean basically. So say, suppose here for the mean here, I'm having, now let's me calculate about the mean. We can see how we can work with the mean now. Now how to calculate this mean? Suppose here I'm having any number I can take. Suppose here I'm having 1, 2, 4, 8, 12, 10. So what I can do if I want to find out the mean, for that I have to add all the data and then divide it by total number of count. How many counts are there? 1, 2, 3, 4, 5, 6. 6 counts are there. So that will become mean. So basically mean is what? Sum of x divided by total number of n. That will give you the mean basically. Okay. So I can call it in this way as well. So adding all the data divided by total number of count. This one is the count. We can get the data. Now, what is the median here? Let's understand about the median. Median is the basically central value here. Central value means what is the central value? Suppose here I'm taking the same data here. Here I'm just taking the same data. For example, I'm having, suppose here, any data here, I'm having 1, 2, 3, 4, 8. Suppose this is I'm having. I want to find out the mean. Mean is basically what? The centralized value. The centralized value here. Okay. So this one is, we can find out the what is the centralized value? 3. 3 is the centralized value because one can say you may leave to this side to this side. So this is a centralized value whenever we are having the odd data, because we are having 1, 2, 3, 4, 5. So total number of count is 5. So for the odd data, we can find out the central value. So here the mean will be 3. But at the same time, suppose I'm having the data such like the even numbers. Suppose here I'm having 1, 2, 3, 4, 8, 10. Suppose in this way. So the total are how many? We are having the even numbers because we are having the total 6. So there we have to take the two central value in case of even number. So what I have to do, two central values, two central position we have to take, leaving all the data aside here to two central position. Okay, two central position we have to take and then we have to just add them. Okay, so 7 divided by 2. So in this way, this would be the median here, right? So here 3.5 will be the median here. So it means 3.5 will be the median. So whenever we are having total number of even data, to find out the median, just add that in between two values by putting that all the values into the ascending order and then just add the 2 divided by 2. That one is the median value here. Now coming to the mod function. Mod function is basically how many times a particular number appearing. For an example, suppose we have to check the appearance of that number. Suppose here I'm having a number, any number. Suppose here 3, 4, 8, 9, 3, 6, 3, 18, 32, 3. So one can see it here in entire range, which is the frequent number appearing the highest part. So if we check it out that data, so we can find it out here, 3, 3, 3, 3. So 3 is that number which is appearing 4 times. So 3 is that number which has appeared 4 times here. So the highest appearance of that number is basically the mod. So this one is the frequency. So here the mod will be 3 here. So highest appearing number will be the mod here. Now here, if we talk about the descriptive statistics, another part, that one is a dispersion of data. So there is one of the term range. Range means that what is the range, how much is the difference coming between the maximum and the minimum here. So if such type of data is there, so we can find out what is the maximum number, 12 is the maximum number. And minus what is the minimum number, 2 is the minimum number. So we can easily find out the range here. So 10 is the range. In this way, we can find out the range here, maximum minus minimum. Now there is another one here. Inside the dispersion, that one is basically the variance. Variance means how much is the variance coming between the mean and the point. So variance is just represented into this way. One can see it here, just a moment. One can see it, this one is the variance basically. Variance will show you how much is the difference coming between the point and the mean and finding out the squared distance here. So here we can see this one. Finding out the difference between the point and the mean here and finding out the square of it. Divide by total number of count here and square of that one. Just a moment, let me check it out one thing. Okay, that one is the sum only. Sum only. So what I can do, just a moment, wait. That one is the only sum here. So here, what I can do, this one only. We can take it here. Sum here only, right? But at the same time, there's another one, standard deviation. Standard deviation. What this will give you? Standard deviation will give you that how much is the data away from the mean. So it is just similar, just like the variance, but only one is going to find out the square root here. X minus mean, the same formula will remain here. So this one is a standard deviation just denoted by this one. So this one is a square here. If we just put instead of this one, only this point, we are just taking it here as a square. So that becomes the standard deviation here. Okay. So let's see it with this one. Suppose for an example, I'm just taking, suppose one is finding out the mean of this data. Mean of this data, and after mean of this data, what one can find out to just calculate this variance here. So one has to give, what is the point here, 2. So 2 minus mean. 2 minus mean by making the square of it. Then again 4. 4 is there, 4 minus mean. Square of it plus 8 goes on. 8 minus mean means finding out the square of it and divided by total number of n. Suppose 4 number are there, 1, 2, 3, 4. So divided by 4. That will be calculating the variance, and standard deviation will be just making the square root of it. So what we can do, we can take one more example for this one to understand how the variance and the standard deviations are working now. So let's see it here. Suppose we are having this one is the equation for the standard deviation, which I had described to you, the same one, just to take out the square root of the variance here, because variance is just this one. One can see the variance here. This one is the variance. Okay, by making the sum of the point and the mean, the difference between the two, by making the square of it divided by total number of n. And the same one is if we are making the square root of it. If we are making the square root of it, that will become the standard deviation. Now let's take a sample example here. Now suppose this one is the data here. Let's see how we can calculate the mean, variance, and the standard deviation. So here, suppose this one is the data 3, 5, 6, 9, 10. These are the values here. What we can do to find out the mean, 3 plus 5 plus 6 plus 9 plus 10 divided by total number of 5 are there. 1, 2, 3, 4, 5. 5 are there. 6.6 is the mean coming here. So mean is 6.6. Now we have to calculate the variance. Variance means what is the difference coming between the point and the mean here. So here one can see 3, what is the point here? 3, let me take all this point here, 3, 5, 6, 3, 5, 6, 9, 10. The same I'm putting it here, 3, 5, 6, 9, 10. Here I'm putting it here, 3, 5, 6, 9, 10. Let me put it here, all the things now. 3, 5, 6, 9, 10. And there it has calculated the mean of 6.6. The same I'm just taking with the mean. Mean is 6.6. Now I have to calculate the variance here, variance. To calculate the variance, one is going to just minus all these things. Point minus mean and making the square of it divided by 5. So how one is making here? What is the point here? Point is 3 here. So one has to take point, 3 is the point. What is the mean here? 6.6. Minus 6.6, making the square of it. Okay, then again plus, second point is 5. 5 minus, what is 6.6 here? 6.6 here, making the square of it, plus 6 minus 6.6 here, making the square of it, 9 minus 6.6 here, 10 minus 6.6. 6.6 and making the square of it. So one is dividing it, divided by total number of components here. 5, 1, 2, 1, 2, 3, 3, 4, 5. So we had just added a 5 here. This will become the variance. So how much is the variance given if we calculate it entirely? 6.64 will be the variance here. So if we calculate it entirely, 6.64 will come after calculating this whole equation. So that will become the variance that is denoted by this way. Now this is a variance itself. Now we have to calculate what? We have to calculate the standard deviation. So how to calculate the standard deviation? Just by making the square root of the same. This will here, this square will go as a square root here, 6.64. Okay, so that will start coming here. What is the equation here? 2.576. So here it will become, the standard deviation will become 2.576. So this will become the standard deviation. So basically, standard deviation is just the square root of the variance. This is set as the variance which has came from here. So in this way, a standard deviation is calculated, right? Now the point is here, like we had studied like all these things now. So we are already having mean, median, mode, range, all the things we are having, right? Mean, median, mode, standard deviation, and the variance we are having. All the predefined libraries are present there inside the RStudio, and we can work with that one. So how we can work it? We can just put any number there and we can directly work with it. So we can see it here. Suppose here I'm having this number. Any number here I'm just taking, any vector we are creating it here. So vector is created. If we say it here, what is the data of x here? So it is just showing you. Now internal sum is there. If we want to make a sum of it, it will add all the sum here. 127 is the sum of all the vector present here. Product is also there. It is showing you the product here. Minimum and maximum number. Suppose max is there, max of x vector. So here it is showing 92 is the highest. And if we check it out here, that which one is the highest one here? So it is showing 92 is the highest number. The same one is showing here when we are clicking here onto the max number. Here minimum number in x, it is showing you as the 2. 2 is the minimum number. One can say 2 is the minimum number here. Two is the minimum number. Range is there. I want to see what is the range. So range is basically maximum minus minimum. So range is maximum minus minimum. So what it will do? Range is 2 is the lowest and highest one is the 92. Now, what is the total length? Length is basically how many total number of components. So you have 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 total number of components are there. Now we want to find out the mean. So it is just adding all the data divided by 9. It will do it internally. So it is just showing 14.11 as the mean. Median, it is showing you. Now here, suppose I want to say what is the median of this data. So what it will do, it is just showing you median of this data is 5. So here, because total number are 9 here, so what it is doing, it is putting all the data in ascending order first, then it is calculating it here. So what it is doing, suppose here, it will be putting all the data in ascending order. Suppose here 2, 3, 3, 2, 3, 3, all the data in ascending order. And then 6, 2 times 6 is there, and then 92 is there, and here 7 is there. Now it is finding out because all the total number are 9 here, total length is 9 here, so it is just looking the data in odd, because 9 is odd here, so we can leave the odd number here. See, 4 number this side we can leave, and 4 number we can leave this side. 6, 6, 7, and 92. So what is the median number? 5. So 5 will become the median here. That's why median is coming as a 5. So before calculating the median, it will put all the data in ascending order here. Now here, suppose I want to put it here as the variance of x. I want to find it out here. So here it is just finding, internally calculating the point minus mean and making the square of it and adding all the data. So once I'll be clicking it here, internally it will be finding out the variance. Wait just a moment. It will be calculated now. Var of x, now one can see here it is just showing var of x is 856.111. Here it is. And at the same time, if I want to define the standard deviation, one can just give ST and the data x is there. So here, clicking it here, it is just showing the standard deviations 29.29. Of which data? This particular data. Now this is one case. What we can do, we can take the file directly and we can find out all these data here. We can find out all the details here for the statistical values in case of the files also. So there is one more summary. Suppose here I'm just writing summary of X. So summary of X also, it will be showing you all the details here. Whenever we give the summary, it will be giving you majorly the minimum, the maximum, the mean, the median values as well. Now what we can do, we can just take out the certain values from the files as well. So suppose here, for example, I'm having the files here, this one here. I'm having the files here. Suppose here I'm just taking, I'm having one of the homo.txt as the file. Inside that, brain volume and brain weight is given there. So if I want to find out the particular brain weight, so what I can do it here, simply I can write homo dollar, the column name is brain weight. In this way I can write it here and can find out here the mean, the median, the range of the same. Or here I can just call the variance or the standard deviation for the same. So here I can just write the same things here. So I can just call the file name, this one, data frame name, dollar, the column name here. Suppose here I'm having one of the data such as empty cars. Inside the empty cars, there is inside the empty cars, we are having certain weights also, weight, miles per gallon, certain columns are present there. So what I can do, suppose empty cars here, I'm just calling. So I want to find out the mean, okay? Mean of empty cars. Okay, this is the data frame name now, which is holding all the data, and the column name here. Suppose mean of mileage per gallon, I want to find it out. I want to find out the median of empty cars, dollar, HP horsepower is there. Now suppose here I want to find out the range of empty cars, dollar, any particular cell SY, CYL. In this way you can just give the name of the data frame and the corresponding column one has to give with the dollar sign. Suppose here I want to find out the variance of empty cars, dollar, MPG even I can find it out, that we can do it here. Standard deviation, I want to find it out, empty cars, dollar, MPG. So standard deviation is just going to find it out internally. Now this one is one. And if I want to take entirely mean, median, mod, range, everything clearly at a one go only, what I can do, I can simply write it here. Here, I can just write it here, summary. Just give me the summary of empty cars. So it will start showing all the minimum, maximum, ranges, mean, median, everything it is going to give me. There is one more data set as there is certain, in the similar way we can work with more data sets. So here suppose I'm having the data set there, iris data set also I'm having inbuilt. Iris data set, it is having the 4 columns. Okay, iris is a flower basically, which is giving you the details of 4 things here. Let me show you the iris flower. Iris flower. Wait, just a moment. Iris flower. So iris is a flower basically. This particular flower. So this particular flower has the ranges. 3 ranges there. Means 3 species is there, and the data set is based on this flower measurements. It's petal length, petal width, sepal length, sepal width. So here, those measurements are present here into the iris data set. So this iris data set is having petal length, petal width, sepal length, and sepal width. These 4 columns are present there, and there is one of the column also present as the species or the class name. So basically, iris is having 3 classes. Iris, we call it a iris setosa. This is one of the class. Iris versicolor. This one is the second species. Iris virginica. So setosa, versicolor, and virginica. These 3 species are there. So we can call these species. Now suppose here I want to check it out that what is the data set here. Means here suppose I want to find out what is the mean. So what is the mean of iris, dollar, petal length? I can take any of the columns, so I can just call it in this way. Or suppose here I'm just taking it here. I want to find out what is the wait. I want to find out what is the median of iris, dollar, petal width. In any column name here I am just taking. So I can find it out. Suppose here I want to find out what is the variance of iris dataset, dollar, sepal width. So that one can find it out in this way. Let's check it out all this now. So one can see it here. Suppose here I'm having an empty cars. Okay, so one can see if I'm just running the empty cars. So empty cars is there, which is having a miles per gallon, cylinder, displacement, HP, weight, gear, car, means many columns are there. Now I can find out the mean. Suppose here I want to find out the mean. So empty cars, dollar CYL, this particular column name it is given. So 6.1875 it is just giving. Now I want to find out the median of empty cars MPG. Empty cars, dollar MPG. So dollar MPG, MPG is one of the column there. So here it is just 19.2 is the median there. I want to find out the range there of the MPG column. So empty cars, dollar MPG. It is showing the minimum is 10.4, the maximum is 33.9. What is the variance of empty cars displacement here? So it is just showing here. Wait, this one. Variance. So variance is 15,360 it is coming. Standard deviation of displacement, it is just showing you the standard deviation 123.93. Summary, if I want to take it out of entire empty cars as a 1. So here it is showing you all the details of each and every column here. Suppose MPG is 1. So MPG, it is showing the minimum, the maximum, the median, the mean as well. Same, suppose CYL is there, cylinder is there. So it is just showing you minimum, maximum, median, mean is well there. Suppose HP is one of them here. One can see minimum, maximum, mean, median as well there. Suppose here QSEC is there, so any column is there. So here it is just giving you all the details of the summary here. In the similar way, we can take any other as well. Suppose HOMO is one of the case there. Suppose I want to find out here all the mean, median, variance, range, standard deviation, summary of the HOMO. So one can give it. Here it is just showing the mean, the median, the range, variance of different of body weight inside the homo uh, file here, and summary here it is just showing related with all the species, body weight, brain volume as well. So in this way one can work it here. There is one of the file there inside Iris inbuilt data set. If here I click onto the Iris data set, so it is showing the Iris data set details here. Iris data set is there, sepal.length, sepal.weight, petal.length, petal.width it is given, and the species name is it is given. So all these are the measurements given here. So here, suppose I want to see what are the details of it, mean, median, standard deviation, variance, and the summary of Iris. So it will be started giving all the mean, median, variance, and the summary of the data. So in this way, we can just check it out that how we can work with the basic statistics in R. So we are done with the basic statistics in R now.